Let us now discuss the light intensity on a screen in Young's double slit experiment. Here you can see there is a direct light YDAC setup on which a light beam is incident on the slit plane, on which the slits S1 and S2 are illuminated, and these are producing interference effect on the screen. Here we can consider that I0 is the intensity on a screen due to each slit S1 and S2. Now in this situation, at the point of constructive interference, the maximum intensity will be 4I0, and at the point of destructive interference it will be 0. So bright and dark fringes are obtained on the screen. Here we know that at a screen center intensity is 4I0, and if we consider at an angular separation theta from center of a screen, say if there is a point P, the waves from S1 and S2 will reach at point P with the path S1P and S2P respectively. Here if we consider capital D is very large compared to small d, and here if we consider theta is small, then in this situation if we drop a perpendicular from S1 to this line S2P, say if this point is S2Q, then here we can assume this S1P is approximately equal to QP. So the path difference between the two waves reaching at P is S2Q only. So here we can write at point P, path difference in two waves from S1 and S2 is, this path difference here we can write S2P minus S1P. This is the difference of physical path traveled by the two waves when these will interfere at point P. And this can be approximately written as S2Q as theta is small. And here if this angle is theta, this can also be taken as theta. So this distance can be written as d sine theta. And for a small theta, we can write it d theta. And if point P is at a distance x from the center of a screen, here we can write theta as x by capital D. So the path difference here we can write dx by capital D. This relation is a very important relation. In many cases, we are directly going to use the path difference at point P, which is located at a distance x from a screen center in the two waves arriving at point P from the two slits. That is given as dx by capital D. So if this is the path difference at point P, here we can write the phase difference in the two waves at point P is, this phase difference we can write 2 pi by lambda multiplied by the path difference, that will be dx by capital D. So this is 2 pi dx by lambda capital D. And we know the intensity at point P is, as the two sources are producing equal intensities I0 on a screen, then intensity at point P we can write as 4I0 cos square phi by 2. Here if we substitute the value of phi, you can see that intensity at point P is given as 4I0 cos square phi by 2 is pi dx by lambda d. So this is the function of intensity at point P, which is varying with the distance from a screen center. As in the previous section, we already studied that the fringe pattern which is obtained on a screen looks like the figure which we can see here, where we can see at center there will be a bright fringe having intensity 4I0, and on the two sides the intensities are varying with distance x, and this function when plotted it looks like this curve which we can see here. In the previous section we also seen this, that the intensity on the screen varies with the position between 0 and I0 on the various points of a screen.